That's the slide of the. That one right there. Unless you want to use the mouse, but you don't like the way I set my mouse.
Okay.
Very good.
So tonight I'm going to talk about Qualcomm Snapdragon X Elite, which is a new ARM chip. And we're going to talk about how it might be able to run Windows on laptops and replace the old x86. Now, if we look at computer development and want to focus on the CPU, or the central processing unit, and the central processing unit is what sits between the software and the hardware. And it's got a language of its own called an instruction set, which is little bitty commands, like go to memory and get a number, go to memory, get another number, add the numbers, take the result, put it in memory. But these commands are actually circuits. They're actually little diodes and transistors. And it's important, this language is called the chip architecture. Now, as engineers, I hit something.
And that's in that exercise plan worked very well.
I should have brought a Linux machine.
For letting us know that we're, it's just not only us.
Stay up front, Johnny. So, when engineers went out to design.
Hey, Phil.
Okay.
When engineers went to design a chip, they've got lots of compromises to make. So two of the compromises I want to talk about is, one of them was they maximized the calculations per second, that is the speed. And we need that because in order to draw all these pictures, it takes a lot of little commands to draw all these pictures. And we remember back in the old 98 days and everything, how everything was slow. However, another thing they could do is maximize the efficiency, or what I call the calculations per watt. Watt is the energy. You know, you get kilowatts, you pay for kilowatts at your house, that's power. So that's the calculation power. And initially, the designers of the CPUs used a CISC, C-I-S-K, or complex instruction set. What that meant is they took 5 or 6 or 7 commands, little commands, and they hooked them together into one. And that was easier for the programmers who were then programming in assembly language. And it was also faster because the CPU didn't have to go out to memory as many times. And the famous instruction set that won out was the x86 from Intel. It was the 8086, and then they had the 8286 and the 8386. And so we all call them x86. So x86 is that language, and essentially the language that started is still here. They've added things onto it, but the grammar and the basic commands are still as they were in 1987, 78. And what they designed for was speed. Every time they could get a decision, they'd make it faster. And it would use more power, and they didn't care. They just made it faster. They just used more power. And when they ended up, and they also made a chip that could do almost anything. It was very versatile. And so from that, we have the our desktops and laptops. All the Windows desktops and laptops, that's where it came from. However, a couple of years after, a guy in Stanford thought development was called a reduced instruction set. And the way he did this is he took the complex and he took stuff out. Okay, and he took all of these multiple things that were 2 or 3 joined together and said you didn't need that. took out everything you didn't need. And he also went what was called changed the kind of the process flow, which you don't need to know about. And that was the RISC. So we had the CISC and the RISC. And the instruction set that eventually came out and is not the most popular today of that type is ARM, A-R-M. And you can think of the R for RISC, if you need to remember it. Now, it was all designed to use as little power as possible. And it was also designed, since it was designed a little later and people knew a little bit more, it was simpler and more efficient. However, they didn't care about speed because what they used it for was little bitty things. So if you had a little bitty thing, you didn't need as much stuff, you got reducing. But eventually, this is what came for our smartphones, because mobile phones needed less power because the battery is not as big, right? It's not plugged in. And also the Internet of Things. And the Internet of Things is what we call embedded, and a cash register is embedded, and a thermostat is embedded. So those don't need much power, the calculation power, so they didn't care, but they did care about the consumption, the wattage. So these two things over the years have grown they've both had hundreds of thousands of people working on them, trillions of dollars, and they've both advanced. And they've slowly started to get to each other, so that the cell phone chips now are pretty powerful. And they're starting to do almost as much as your laptop. And your laptop now, you see how thin this is, it's getting pretty low on power. So they're coming, and so if I had to ask somebody today, rather than 40 years ago, what do you want? Do you want more speed or less power? And you would obviously say, I want both. Okay? And so that's kind of where we're going tonight. There's plenty of years of work, maybe a decade now, or a little more. People have been trying to take these RISC chips and let them run the CISC, the x86 language, as fast as what these do, but use as less power as our cell phones. Okay. Now it turns out if you give some practical rules and about what you mean by that, Apple achieved that in 2020. And they came out with what was called the M series chips, the M1, M2, and they are Apple Silicon, which means Apple designed all the circuits, but they used the ARM language and the ARM basic low power design. So Microsoft and Windows has been trying to do that. And somebody finally, Qualcomm. Qualcomm is one of the big sellers of smart chips, probably an Android, probably a Samsung or something like that. Top of the line will have a Qualcomm chip. And they now claim, and I will say claim, and we will see and judge at the end whether we think that might be true, that they have a new chip called a Snapdragon X Elite, which is an ARM chip, which they have designed to run Windows, and they say will do the job and match the Apple and move back in parity. So that's the topic. Are we going to see a new chip or Windows that works a whole lot better than we have now? So if you look at from an electrical diagram, from electrical component part, a computer has the RAM memory, and it has the CPU chip. And then it's got a whole bunch of chips that interface with the actual hardware that you plug in. So all the display and the keyboard, they have to have chips that interface and send stuff to it. And your hard drive, it has to have a chip that sends it to the hard drive because the hard drive is plugged in. And if you want to get on the internet, it's got to have a chip that works with the plug that you stick in for the internet. And just to show you that in a computer, you actually load your programs and all your data in the memory, and the CPU and the memory go back and forth, and that's what's running in the computer. And when you get finished, it takes it and it moves it to your hard drive to save it or whatever, to put it on the screen. Now, what they did in the early days, of course, each one of those little chips was different. And here is probably a computer from 20, 25 years ago. And you looked on the inside and there was lots of stuff. Lots of all these little pieces and parts. And in a computer, if you move things within a chip, it doesn't take much power. But if you move it from one chip to the other, you've got a wire or copper way. And it takes a lot of power to get it out of that chip into the other chip. So anytime you've got individual chips, you got a lot of power. So here's what, to the right, you see a power supply that we used to have. Let's say it's about 300 watts. You know, they use 200 to 500 watts. And if you put your hand on top of the old, we all know, because nowadays I don't know. But if you put your hand on top of a 300 watt bulb, it's awful hot. So you can see in the power, it's got fans all over the CPU. It's got a fan, it's got a fan to the right, a fan to the left, lots of heat, lots of power. Okay, never could run this. Your cell phone could never run this. Okay, and so that's the way the people who were on the "let's make it faster" group were going, and they spent a lot of time getting that perfected. But as time went on, things got better. And basically what happened is we had miniaturization. Everything got smaller. And about a year and a half ago, I gave a talk on all the chip fabrication and all this kind of stuff. And basically all you need to know is they've gone from 1,000 or 5,000 to 3,000, 130, down to 5 nanometers for each little piece. Actually, the width of a gate, but just call it a little piece. Now, a nanometer, think of it like it's somewhere between a millionth and a billionth of an inch. So think of this as 5 millionth of it. It's too small for us to worry about. Okay, it's way, way small. It's getting down to the size of atoms. Atoms are a little under 1 nanometer. Okay. So with all of this, they found they could put more things on the chip. And there was something called Dennard scaling, which said the power to run the chip only cared about the area. So if you kept the same area and you cut things in half, you could put 4 times as many things on the chip and use the same amount of power. So that's why everybody's power has gone down. And so the people who were the fast people, the complex people, the CISC people, we just put more stuff in there. There's room for more stuff. It's like somebody have a house, or there's a closet. It feels like closet. Okay? And the people that said, let's use the power said, whoa, with the same amount of things, we can make it 1/4 the size, and therefore we use 1/4 the power. So we can use that advantage to make everything go away and make it smaller. And so they went down that design road. And eventually they said, well, it got so good, they said we can add extra chips. We can add a GPU, which is for the graphics card to help the graphics. And we can put more than one CPU on the same chip. We call them cores, multi-cores. You get all kinds of advantages for that. And then they came out with a new thing called the NPU, which is the neural processing unit, which is a domain-specific type chip for artificial intelligence. And you see that cropping up these days. And then people said, well, we got these chips are small, and why don't we put them all on one big chip? Okay, and so we call that a system on a chip. And said, hey, we'll put everything on a chip that we can. And that's called the SoC. So if we look at what I told you before, now we've got the CPU, the GPU, two CPUs, the GPU, the NPU, all the little chips that go out, and they're all on one chip. Now, who paid for all this development? The billions of people that bought smartphones. That's what all the money's been going in and developing and paying for all these improvements, you know? I mean, we think of all the billions of smart people says, well, we can sell billions of them. They said, here's the capital. Go invest and build a plant. We can do it. And we might take a little profit back at the end.
I think they hold on to too long. Oh, well, we'll give them these new.
You always got to get a new one, right? So let me talk about the ARM chip. When I say ARM, I'm going to be talking about there's two basic technologies. One, of course, was the RISC thing. You know, that kind of that design concept and that type of chip. And the other thing was the SoC. So you combine these two things together. And why is that not working?
That's an old version of software,
Tiny.
It's not a small chip in
not a smartphone.
This is not.
it.
This you didn't put the
Yeah.
PowerPoint on, did you?
Don't think so.
Okay. Put me put the PDF on. I don't know what. Oh, I know what it is. You got high resolution on. That's a 1080.
I'll go ahead and change it. What do you want?
1080p. 1X. You got it at half. You gotta go to
No, that's displays. My other display ain't
Scale.
ain't connected. There you go. Display resolution. You want 1080?
yeah.
That's
Try.
I don't.
Try it. Try
1080's
this.
down the bottom, okay? Keep changes.
Well, that's cheaper than 13 on regular phone. Yeah. With the Snapdragon.
No, that ain't it. It's just scaling factor. It's not the resolution. Go ahead and put it. Let's try this.
Get it up PDF.
Can you make it display mode? Technology is supposed to be advanced. Display. You got to go to display mode. Presentation mode.
I don't know if this PDF reader's got one.
What is it?
It's something. You.
It's usually,
Should be in there.
it's display mode. What browser you using?
It's not a browser.
Oh, go to your browser.
Uh, What browser you want to use?
Firefox.
No, get blocked.
Open with.
Okay.
Some organizations.
So this is a chip, an SoC chip, and it's next to a dime. All right,
Wow.
to represent the size. And you can see the bottom of the chip is on the left, and it has several hundred connectors. Because that's going to connect to all the parts in your computer or your smartphone. Okay. Now, the actual CPU I've represented here, and it's got a couple CPUs in it, a couple cores. And now here is what's on the chip right below it. And notice this little thing I've drawn in red, the Cortex A15, is the actual ARM chip. But next to it, we have a GPU and a controller address, a CAN, serial, peripheral interface, an asynchronous, your display, the crypto, all these things that would normally used to be individual parts that are all on the chip. This is the system that connects with all the other hardware. So the actual CPU, which I'm talking about tonight, is from ARM, which is a company. And they originally called themselves Acorn, and then there was Acorn Risk, and then it's just like Google or something. It's just a name now. And they're out of England. And what they do is they came up with the language and they wrote the specification and they got the rights to the language. So if you want to use it, you got to pay them to use the language. And it has to be what we call binary compatible, so they all work together. And they've had several versions. You'll see ARM v6, 7, 8, they're at 9 right now. They also, besides licensing you the right to use the language, will give you like a blueprint called a hardware description Verilog language. And you can go out and build one yourself. They've already figured out one, and you can buy from them. So the people that sell the chips have a choice. They can just license the right to use the language and build their own circuits, or they can just buy the circuits. If you're just doing a thermostat, you're not going to go out and do a circuit. But if you're Apple, you're going to go design your circuit. You're going to make the new M chips. And then the people go out and they do the same thing for all these little pieces. People have designed and they have little diagrams that they can buy for all the other little types of devices if they want. And once they get all that together, nobody builds these chips anymore. They go out to what's called a fab shop. All right. And the two for these types of chips, of course, we have Intel and then AMD. AMD now uses global fab. But so the two big ones, besides the umpteen in China, are Taiwan Semiconductor Manufacturing Company, TSMC, which makes all the Apple chip. And then Samsung, which is going to make the Snapdragon, makes a lot of memory besides the chips. And they're from South Korea. So these people, TSMC and Samsung, are very sophisticated, just like Intel and AMD. And they're very sophisticated in making things and designing things. So here is a computer run on an ARM chip, one that I have. And you can see that the thing in the circle is the system on a chip. And it's this little thing under the heatsink. And then it has a memory, one memory thing, which has 8 gigs. Okay, less than the size of a dime. And then most of the rest of it is just so that it has connectors that human beings can stick their hands in. That's the only reason it's this big. So when you
That's a
see
whole
it,
computer. Plus,
huh?
that's a whole computer right here.
As a whole computer, I've put many Linux distros on it, and it, you know, you have to hook it up to a keyboard and the display, but it's a real computer.
It's the computer part, you just have to add
The actual hard drive, the hard drive is a micro SD. That's the hard drive. Okay, I'll stick it in here so it doesn't get lost.
Yeah.
I usually use a USB 3.0 stick, but so all of this has been miniaturized. All that stuff that used to make all that noise and heat is now, well, you know that because this is more powerful than any computer you had in 1998.
Yeah.
So you already know that.
In 2000, you know,
Oh, yeah.
Okay?
but they charge a lot more, like, you put everything on one little chip where you used to have all these things. But they don't, how much do they charge for those one tiny little chips? Not much,
You get the cell phone free sometimes.
Oh, those are 30, 40. Okay. You have to buy good ones if you expect them to last. And they cost a little more money than $2 or $3. Okay. They cost maybe $30, $40 for a good one. That's fast enough, and I'm not gonna get into all that.
no.
Would you say buy for what?
What?
What did you say? Why should we buy Google for what?
I didn't say you should buy Google for anything. I'm not sure what you said, so.
Okay.
So let's look, because we were talking the CISC and the RISC, and really the companies we're really talking about now are Apple and Microsoft. Okay? So let's see
Everybody else.
Apple's history in the CPU chip land. They started out after the Apple II, which is old 8-bit land. When they came out with Macs, they had a CISC from Motorola. Motorola was their guy rather than Intel. Well, Motorola couldn't make a 32-bit work very well. So they designed their own between Apple, IBM, and Motorola. They made the PowerPC. They also started giving venture capital to the ARM company. They've been dealing with the ARM company since the 90s. Okay, and so in 2006, they couldn't keep up with Intel because Intel was getting better. So they transitioned to Intel Macs. All of a sudden, the PowerPC went away and they had Intel Mac. Now, after a while, nothing was happening with the Mac. You know, 2014, 15, people are saying, when are they going to come out with a new Mac? I don't know how they changed this. They put a little thing you could touch with emblems on the top, but they really weren't improving very much. So, because of course they were working on the cell phones, becoming one of the world's largest companies selling cell phones. And eventually they said, okay, let's make a quantum leap And they came out in 2020 with the M series, the M1, M2, M3 for the Mac. And to show you how that does, here is their chip, kind of a die, what they call a die picture before they put the top on. And so to the left, you'll see it has a CPU, but it has 8 cores, 4 efficient and 4 performance. So it's got 8 things going, and the CPU has got 8, and then the NPU has got 16. And so that's kind of, so these things have gotten so small, they're using the best technology practiced industrially from TSMC. And so they could do all this, plus they figured a way to make the x86 language work, Rosetta, and all this other, and lots of other stuff they did. Okay, they did lots of work. And so this is their way of saying sayonara to Intel. Okay, because they got high power, good graphics, long battery. Why, you know, hey, Intel hasn't delivered. They have their own proprietary thing that they can charge a whole lot, and they have a great machine that's been very successful. And so they've gone to M1, M2, M3. Here is the M3. These are the die pictures. And so the M, they have 3 versions, like the regular is about the size and power of the original one. But what they've done is now they've gone to 12 CPUs and 16 CPUs and 40 GPUs. So people who need this and will pay for this, they can get this power, and they have, this shows you that their technology is so good that because if you make one little mistake, the whole thing is trash. So the more things you put, the more things you got to get right. Okay, and this shows you that they're good. All right, so this is the leading edge commercial technology for us consumers. Well, what about poor old Microsoft?
Who were they?
Microsoft,
They're not cool.
No, they're not.
well, you got it from the CPU perspective. So, they were late to smartphone. They were too busy trying to figure out how to get everybody to use Internet Explorer, and they didn't worry about the smartphones, and they got taken over by Apple and Android. And so when they got in, that, you know, all the apples had been picked off the tree, and they tried, but they failed. All right. So they said, okay, about 2014, they said, well, you know, we could make this compromise machine. You know, it would be, we could make something that kind of runs fast and is kind of low on power. And they call that the Surface. And it's like a tablet with a keyboard on it, and it had the little kickstand. I'm sure you've seen them. And the first ones, they called it the RT, the RISC technology. All right, that RISC comes up because it had a RISC chip. It actually had an NVIDIA chip. So they tried, but they failed again. And eventually, what they did is they said, okay, we like the machine. We'll go get an x86 chip, and we'll kind of reduce some stuff ourselves. We'll make a cheap x86 chip. And again, it's just compromise, it's balance. And about that time, the other competition was Google. The Google Chromebook. So you all know the Chromebook. Well, that's what the Chromebook is. And Chromebook said, well, just go to the internet. You don't need all this. You got reduced stuff. It doesn't need as powerful because you're going to do all your apps on the internet. Well, Apple hadn't been doing that on the internet. They had everything, you know, Microsoft Office, all these things on their computer. And that didn't do well. So they said, okay, all of our enterprise, all our business people, we'll just bring them to the internet and use the big machine. and we'll plow in that field. There's still plenty of money to make over here, okay? So Intel had been they're not a bad company, they're good engineers. So they're making these x86 laptops better and better also. I mean, they're not sitting on their hand. So they were successful, but they could not deliver the more efficient, more modern RISC chip. Okay. So I don't know, half a dozen years ago, Microsoft said, okay, we'll go to somebody else for our low power chip. And they happen to go to Qualcomm, who's what I'm talking about tonight. And so they've been doing business with Qualcomm and giving him secrets and, helping share how does Windows work, all this kind of stuff. So they're not just sitting independent. And Qualcomm started making chips. Now let's talk about who Qualcomm is. Qualcomm is in San Diego, and they're, of course, multinational and all this kind of stuff. And they're a wireless communication company. Anything to do with Wi-Fi, they were there first. And if you remember back in the early candy phone days, they had two types. They had the CDMA, and then they had the World Phone, the GSM. Well, they invented the first workable cell phone, CDMA. They got the patent. First mover. All right. You get the money when you're the first mover. All right. And then the Europeans said, oh, no, you can't do it by yourself. And they came out with another one. And today we got both. So this got them set up. And they today have about a 28% share in all these things we call the SoC market, because all cell phones use SoCs, right? Because we can't have all those big power supplies with us, right? We got to have the SoC. And they did what was called a fabless model, which means they design it and they send it off, somebody builds it, and they get it back and sell it. They don't have a fab shop, because fab takes trillions of dollars, billions, not trillions, billion, many billions to build. And they have been making laptops with Windows since 2018. And I'll show you the latest one that you could go out and buy, or one of the later ones. There's a Lenovo ThinkPad X13, Windows 11, and it's got a sort of a modified chip called the 8CX Generation 3, but the C means this one's kind of made for more for computers. And you go get one with 16 gigabytes of RAM, a terabyte of storage, 18 hours of battery life, 5G turn on speed, and $1,000, kind of your premium type, not super, but your premium type business laptop. Well, for $1,000, you can get a regular one that's a whole lot better, people say. It's not bad, but it's not great. So why do I spend $1,000 on something that ain't great? Well, if you need it to be real light and you need an extra few hours of battery life, okay. But it's still not the performance of the regular ones. So they, this October, said, we did it. We beefed it up, and now it's good. We took that old 83CX and we made this new, and they have to give it a name, right? The X, Y, whatever it is, Elite something. Give it a fancy name. And they said it will run Windows on ARM with improved speed. And why can they do that? Well, the people that built this great Apple M series chip, the engineers left the company and started their own company and said, we're going to build a chip. Now, what you want to do when you want to cash in as an engineer, you start a company to show you can do it, and then somebody with the big bucks and all the salespeople buys you. And you go,
Retire.
retire. Okay, so that's what they did. They bought the technology. And of course, Apple wasn't exactly pleased with Punch, okay? So there's lawsuits, but they'll all just, it's just money will change hands and they'll give them a cut or something of the future profits and everybody will be happy in the end. Everybody, you know, we just give them money. We're just giving money to the lawyers every time you buy one of these things, okay? Okay, so they say they got the chip, they designed it, they built it, but they haven't put it in computers because they got to get with Windows and all the PC makers and build and things for you to buy. And they say you'll be able to buy it towards the second half of this year. That's their problem. Now, why should you buy this? Because they say if you could look at an x86, you know, kind of a 14th gen, pretty good x86, running Windows. You can run Windows on this one twice as fast. Or you can run it at the same speed and use a third as much power, i.e. 3 times as much battery. Okay. And then they said if you compare it to the M1 and M2, it's going to perform equivalent, whatever that means. This is their claim. And so they've got the Apple engineers. And they've been in the business for ages, and they've been working with Windows for ages. So, I mean, this isn't like just guys coming out the cane patch, you know? So what does this thing look like? So this is kind of, I've made a block diagram of the new chip. It's got 12 CPUs. Okay, good. There's a law called, what, Amdahl's law or something that says you can only get so many and then you get diminishing returns. Generally 6 to 8 is generally considered the sweet spot, but they went to 12 and running at 3.8 gigahertz, which is pretty fast. So there's got to be RISC chips because 3.8 gigahertz generates a lot of heat. So they might have fans in these things if they hook them all up. But in order for this to work, they've got cache memory. Now, cache memory is what we call SRAM. It's very expensive, but very fast RAM that is on the chip. It is not in another place. And it's got to have plenty of connections because if you're running 12 of these things, but only 2 of them are working, where are you? You know, you got to be moving back and forth and have all of them working to get the benefits of this. Is one of the tricks of skills you got to have when you design these kind of chips. So all of this is kind of new. And then they've always had a GPU. They have their own GPU, which they say runs high def, you know, so you could plug it into your UHD TV, or 2 of them. And they also had their own NPU. You know, Apple had an NPU, they got an NPU, Intel's got everybody's got an NPU now. But they've got one that they can design and build in their own chip. Plus, they've also got interfaces. So when you go from the cell phone, you don't have that much to display. You got the little bit of screen. But here now you got to have the things for big screens, and you got to have a lot of storage, you know, no more 256 gigabytes. You need 3 or 4 terabytes, you know, so you got to have all these kind of NVMEs, and then you got to have all the USBs that you're going to hook up to it, because it's not like a phone where you got one USB and you use the power. You're going to run all your stuff, you know, all your various connections, and it's got to have the latest, fastest USB type. They're going to even have USB 4, which is just coming out, and I'm sure a bunch of other stuff. So it's not just the chip that they've designed and it's faster because they got the technology that kind of Apple traders help them with. But they got all the other stuff because they've been in the business forever. They have been in the cell phone business. They have been in the low power business. And Windows is helping them design to work on Windows. So why develop now? Well, Apple has disrupted the top end of the market, and Microsoft needs to catch up. Intel has not delivered, so this is a chance for Qualcomm. And if you look at Qualcomm stock today, I think it went down. The smartphone business is now cutthroat, right? There's very little profit left, unless you're Apple, unless you have a big brand name, maybe that people want to buy. It's just all the Chinese manufacturers have come in, the knockoffs, all that kind of stuff. So they need more markets. They need to be at where the money is, the new stuff. There is an emerging need for AI. If you look at the new Samsung, whatever it is, you'll see that now not only you have a camera, but the camera does all these things like that. They make things appear and your friends disappear. All these things are AI driven, kind of, to do that kind of stuff. And of course, Qualcomm bought its way into the Nuvia business. And then Qualcomm is pretty good about connecting to 5G, all the fast connection 5G that you see popping up, whether you believe in it or not, they're ready for it. And then there's if they had this kind of chip, there are new areas that could use this power. And their kind of expertise in other things other than laptop, virtual reality, automotive, the displays and the self-driving car, if you get in front of any of those. Handheld gaming, the kids want things smaller, they want to put in their pocket and have the power of a theater. And other IoT things, which are now getting more sophisticated. So they think there's a reason to do this. They've had to invest a lot of money and a lot of people. And so they think it's worth it. And they think they're positioned well. So, closing thoughts. Qualcomm claims, and I kind of believe them, to have developed an ARM chip that can run Windows as fast as x86 chips at a low power level. And that this will put them on a par with the current Apple M series. They're now working with all the vendors in Windows to actually put things out on the market. So why I'm here is to say you're going to start seeing these probably at the end of the year. You're going to see this is a new thing. Now, many issues have to be solved, probably, but I think they've got their 8 ducks in a row that they ought to be able to solve. Maybe it won't be the end of this year, maybe it'll be the middle of next year, but I think it's going to be solved. To me, it's kind of like, how fast will it come out and how expensive or impressive will it be? How many people will it get on board? Business stuff rather than technical stuff. And assuming this works, it's finally time, after 50 years, to move Windows off of the x86. That was designed a long time ago. That was designed in the Apple II era, to be specific. And it's getting harder and harder to make it perform for the modern thing. And these ARM chips have more efficient designs that are better for the future. So. Questions?
What about the apps? There's millions of different apps that all for Android and Apple. Are they all gonna have an app for Windows?
They're gonna have an app. There are two ways you can do it. And one way is to have kind of a translator. And one is an emulator. I guess Apple does more of a translator type. But essentially, you take the existing x86 apps and they work. Will the Android apps work? I don't. If you put it in an Android machine, but there's no reason for Windows to develop Android if they don't want to. Okay, so the goal is to take all the existing Windows software and it works on this without any hocus pocus. So it's just like you bought a Windows machine, you don't care what the processor is. You just know it has a long battery life and it works just like the old one. And it works faster. Okay, that's all you care about. Now, they're not doing Linux, but Linux figures it out on their own. It's just another chip. Linux is running on I've been running for 4 or 5 years on a phone chip. Somebody in Linux figures it out, and they do it, you know. It's a different business model. It's not a business model almost, okay? It's a open source model.
Right.
So the trick here is to replace the x86 computers with a better system.